if you're seeing my screen here, I'm going to draw a right triangle. And I'm going to say that this side is 8. This side is 12. And I'm going to ask you to find the unknown side. I'll just remind you of the Pythagorean theorem here. It says that if I give you 3 sides of a triangle, you have A, B, and C. A squared plus B squared equals C squared. You could give that a try, and you're welcome to use a calculator if you need to on that for squaring.
Okay.
So I'm just going to start here with a few steps. We have 8 squared plus 12 squared equals x squared. 64 plus 144 equals x squared. So you add those together, that's 208 equals x squared. From here, you take the square root of both sides. The square root of 208 we can reduce, and that's why I chose this problem. Do you recall how to reduce square roots?
I don't.
Okay, so use a prime factorization. So I've started that over here on the right. 2 is the smallest prime number, then 3, then 5. And you don't have to go much past that, but you make a tree here. So 2 times 104 gets you back to 208. 2 times 52 gets you back to 104. 2 times 26 gets you back to 52. And then 2 times 13. And you might think, well, how do I know when to stop? You stop when you have all prime numbers on the leaves here. 13 is a prime number. And then you look for pairs. So this is a pair, this is a pair. And for each pair, you bring that number out. So you bring out a 2 for this pair of 2's times 2 for the second pair of 2's, square root of whatever is left over. So that's 4 square root 13 equals x. Yeah.
Okay.
Okay, so as sort of just a related question here, could you determine the square root of 120 using the same approach over here? I'll write the prime factors 2, 3, 5, 7, 11, 13, and so on. Give that a try, please. I'm going to start working this out. 2 and 60. So if you build your tree, you should get something similar to what I've written down here. There's only one pair this time. That's why I chose this example, because you only bring out pairs. So 2 square root, and what's left over? There's a 2, a 3, and a 5 left over. You multiply those on the inside here. So that's equal to 2 times the square root of 2 times 3, 6, 6 times 5, 30. Would you like another example of this, or can we move on to continue working on triangles?
Just one more, please.
Sure. Let's do the square root of, let's go 500. So again, you're just going to break that apart. I'll write the prime factors over here. Okay, I'll start breaking that apart. 2 and 250, 2 and 125. Here you may have gotten stuck. You try 3 does not work, but 5 does. 5 goes with 25. and then 5 and 5. Is this what you were able to get, or?
Yeah.
Okay, so here you can circle a pair of 2s and a pair of 5s. So there's a 2 on the outside, a 5 on the outside from each of those. Square root of whatever is left over, which happens to be that 5. So this becomes 10 square root 5.
Okay, that's what I got too.
Awesome. Okay, so let's do one more of these triangle problems here. This time I'm going to give you the hypotenuse. Let's see here. I'm going to go 20, and we'll call this 8. And I want you to find x. Again, I'll write out the Pythagorean theorem. A, B, C, a squared plus b squared equals c squared. So you're given b and c this time, and you'll have to manipulate this equation to find it. Okay, so you should get something like x squared plus 8 squared equals 20 squared. X squared plus 64 equals 400. Subtract 64 from both sides, you get x squared equals, this is where you might, if you haven't done this in a while, you might want to grab a calculator, 336. Okay, and then you just break this apart just like we did before. You're taking the square root of both sides. So 2 and 118. I think, nope, I'm sorry, that's completely wrong. I need to refresh here. 178. No, that's not right either. 68.
Yeah.
Thank you. 2 and, so you keep trying 2 and 84. 2 and 42. It gets easier once you get down to smaller numbers, and then 3 and 7. So we got one pair, another pair. So bring a 2 and a 2 on the outside. Square root of 3 times 7. So 4 square root 21 is our answer for that. All right, so now let's do, you said, hey, I want to do some geometry stuff. That's stuff they're going to emphasize in Algebra 2 is the kind of the trigonometry. But let me do a little bit more with triangles before we move to some other stuff here. So let's say I give you a right triangle, and I give you the hypotenuse is 15, and I tell you that this angle right here, this angle is equal to 20 degrees. Do you recall how to find x? Do you remember the 3 trigonometric functions that you use most? It's okay if you don't, but
SOHCAHTOA?
yep, that is useful. There's sine,
Oh, yeah.
there's cosine, and there's tangent. What you told me is how you use them. So sine is the opposite over the hypotenuse. Cosine is the adjacent over the hypotenuse, and tangent is the opposite over the adjacent. So the sine of 20 degrees equals, let me put a y there, the opposite side, so the opposite to this angle, y, over the hypotenuse, which is 15. The cosine of 20 degrees equals the adjacent side. So the adjacent is the one next to, not opposite and not the hypotenuse. So x over the hypotenuse, which is 15. So I'm just following these formulas here. And then the tangent of 20 degrees, is y opposite over x adjacent. If any of this is unclear, let me know. I can review it again or give a more straightforward example of this.
Okay.
So let's just start with something. Sorry, this thing jumped. Let me back up here. So the more likely question for you to get is something like this. Okay, here's a right triangle. Here's A, and they tell you that this is 5, this is 13. Okay, and they want to know they might ask, what's the sine of A, what's the cosine of A, and what's the tangent of A? Well, and for these three, you need all three sides. So we got to find this missing side first. How do we find the missing side of a right triangle? Well, we did several examples already. That's the Pythagorean theorem.
Mm-hmm.
So you've got to, it's understood that you're going to do that first. A squared plus B squared equals C squared. You're going to find the missing side. Okay, so that's like 5 squared plus B squared equals 13 squared. 25 plus B squared equals 169. Subtract 25 from both sides. So B squared equals 144. And then you end up finding that B is 12. So it's expected that you know how to find the missing side.
Mm-hmm.
And then, like you just said, sine is so koto, so S-O-H. So you have to look relative to A. What is opposite? 5. What's the hypotenuse? It's 13.
Okay.
Now cosine of A, you said, okay, so okay, C-A-H. Okay, so the adjacent to A is 12. The hypotenuse is 13.
Mhm.
And if that's clear, tell me the tangent of A. Give me the two values for that. Tangent is TOA. So what's opposite? What's the opposite side to A?
5.
5. And what's the adjacent side to A? That goes down in the bottom. It can't be the hypotenuse. It's not that one.
12.
So it must be 12. Yeah. And maybe that's, I guess I don't explain that very often. But if you're here, if this is adjacent, this is opposite, and this is the hypotenuse.
Mhm.
But if you're this top angle, this is maybe where it gets confusing. If you're this top angle up here, the opposite is down here, the adjacent is right next to it, and the hypotenuse is in the same place. So the hypotenuse is always in the same place.
Okay.
And that should hopefully clarify this. Okay, so let's do another one here. Let's say this is the triangle. I'll make it a little different just to vary that. This is C, and I tell you that this is 10, this is 6, and I don't give you this side, but I want three things. I want the sine of C, the cosine of C, and the tangent of C. So there's two things you've got to do here. The first thing is you got to use the Pythagorean theorem to find the missing side. This one right here. And then the second thing is you have to use the so katoa to figure out these values on the right.
Okay.
So first thing I want you to do is let me know when you're done is solve for the missing side. I can scroll up if you need me to. If you're already sure to do it, then just go ahead and give it a try. give it a try.
Huh? What's that?
Okay, so is the missing side 8?
It is, yes, very good.
Okay.
And the rest of it depends on that. So you really have to make sure that you have that down. So the sine of C, here's the angle C, you need the opposite and the hypotenuse. So the opposite side is the 8. The hypotenuse is always the hypotenuse. It's the one across from the 90-degree angle. That's 10. Notice this fraction reduces.
Hmm.
And you would be expected to do that. So I know I'm throwing in a little bit of a wrinkle, modifying the questions a little bit, but these are all things you will remember to do when you're in the exam. So go ahead and give me the value for cosine C and tangent C, if you can.
Is it 3/4?
For which one?
Cos.
Cosine. So cosine is the adjacent. The adjacent is 6 over the hypotenuse. What is the value of the hypotenuse? Because it's always the same. It's 10.
Oh, 10. Okay.
10, yeah. Okay. And that reduces to 3/5. Tangent is the opposite over the adjacent. So that's why I wasn't sure which one you're referring to. This reduces to 4/3.
Okay.
All right. Do you want to do another triangle problem?
I think I'm good. So for the test tomorrow, I got an email and it said that it's just going to be like the basics and I can't use a calculator.
Okay, well, that's good because most of what we've done, I don't think we've done anything with a calculator yet.
Yeah.
All right, so here's another geometry question that I think, let me just snip it in here. So basic could mean a lot of things, but I'm gonna go off the assumption here that they might give you something like this, which is a kite. They wouldn't ask you why it's a kite, but they would want you to determine the values of the variables. And if you recall in geometry, there's really kind of two things you do. You either set things equal, or they add up to, something. Could be 90, could be 180, could be something else. Here, these two are congruent. So these must equal each other, and that's number one here. So 2x plus 2 equals x plus 11. So could you go ahead and solve for x, please?
X equals 9.
X equals 9, great, okay. So that means that you can use that information to, for example, put that number back in to each of these values. So like 9 plus 11 is 20, 2 times 9 plus 2 is 20, but you should say to yourself, well, I should have known that, like they're both 20, so I'm confirming what I already know. But it does allow you to figure out the value of y. You can do that because you say, oh, this is 9 plus 2 or 11. So what must y minus 2 equal?
13.
You're giving me the value of y. Yeah, you've already gone ahead and solved it. Y minus 2 equals 11, so y must equal 13.
Okay.
Now, the one kind of thing to remember here is that sometimes they ask you for the value of the variables, and then sometimes they ask you for the lengths. So just be aware of that. So let me, I wasn't able to pull up another question without, let me, those. All right, let me make one up here. So you might see a question that's something like this. It says this angle right here, and it says this angle is 2x minus 20, and this angle is 4x. Let me get the numbers here. Give me a moment here. They might tell you that these are the angle measures.
Okay.
So I set up above, I said you either set things equal or they add up to something. So what do these two angles have to add up to in this example?
90.
90. So you would say to yourself, what's 2x minus 20 plus 4x plus 20? That equals, like you just said, 90. Okay, now the question could be written, and I'm gonna type it here. There's two types of questions. I say, what is the value of x? Or it could say, what is the measure of each angle? In the first question, you have to actually find the value of x. In the second one, you still have to find the value of x, but then you take that and put it back into each angle. So the first thing I'd like you to do here is solve. Let me not write it there. If you got some paper there, let's have you solve for x.
Okay. X equals 15.
X equals 15. Excellent. Now, that's question one. Question two could be, what is the measure of each angle? Or, I mean, it could even be more specific and say, like, what's the measure of angle A, or what's the measure of angle B? So be prepared to use that number and put it back into each angle measure. So go ahead and give me this first angle and then the second angle, please.
For the first angle, I got 10.
Agreed, 10 degrees. And then the other one is gonna be what?
$80.
Yes. Very good. Okay, let's transition a little bit away from these unless you remember something else that would be good to cover here. Going to go back to some factoring.
Okay.
So I found this question on an entrance exam into Algebra 2, so I think it's a good candidate to look at. It says to factor 2x cubed minus 4x squared plus 6x. There are many different types of factoring that we could go through. The very first type of factoring is greatest common factor. And the greatest common factor can be either a number or a letter or both. So it can either be a number or it can be a letter or it can be both. So what number is common between 2, 4, and 6? What is the number that goes into all three of those?
2.
2. And then when it comes to variables, what you actually look for is the smallest power. So in this case, it would be x.
Mm-hmm.
So next you write, well, what goes in here so that when I multiply by 2x, I get back to this. So that's x squared minus 2x plus 3.
Mm-hmm.
Okay, now this looks like it factors. Actually surprised that they've done it this way. But you're looking for two numbers that multiply to 3 and add up to -2. So when you look at 3, you say, oh, well, it could be 1 and 3 or -1 and -3. Do any of those add up to -2? And the answer is no, they don't.
No.
But like, let's just say it was -3. It's not, but let's just say it would be -1 and 3 or 1 and -3. Those add up to -2, the second one here, but that's not what we have here. We have a 3, not a -3. So that's why you're actually done right there.
Okay.
Okay, let me make another one here. 4y to the 4th minus 8y cubed minus 12y squared. And again, the game here, the question they're asking is to factor. And you're going to use greatest common factor for that.
Okay.
So give that a try. At least tell me the greatest common factor whenever you know that, or ask me if you've got it correct.
It's 4y, right?
A little bit more. So the nice thing is if you get the wrong one, you'll notice that something still factors out. It ends up being 4y squared. It's always the smallest exponent of the group.
Okay.
Do you follow that? Maybe.
Yeah.
Okay. So now let's figure out what goes in parentheses here.
Y squared minus 2y minus 3.
Great. Now, does this, what's inside here, does it factor? So it's kind of the same as above. Is there a number? There are two numbers that multiply to -3. We already have them over here that add up to -2.
The second one, 1 and -3.
Yeah, so you'd write it as y plus 1, y minus 3. And you would consider that done.
Okay.
One more example, just to emphasize that it could be more than one variable. So let's say it's 20x squared y cubed minus 30x y to the 4th. Let me go, yeah, plus 5x cubed y. So this one's more complicated in appearance, but it's the same strategy. You first look at the numbers and ask yourself, what's the biggest number that goes into all three?
5.
5. Then you look at the x's. So there's x squared, x to the power of 1, x to the power of 3. Which is the smallest exponent?
1.
1. So you say x here, and then you look at the y's. Y cubed, y to the 4th. Let me just make this y squared to make it a little different.
Okay.
Which is the smallest one? It's y
Squared.
squared. Okay, so now you figure out what goes in here. And this is where you got, it's a little more complicated. Okay, 5 times what gets you to 20? That's 4. X times what gets you to x squared? X, y squared times what gets you to y cubed? Y.
Y.
So see if you can get the rest of these filled in here. I'll come back and help. I'm just going to look ahead to a new topic for us to cover here.
I said 4xy minus 6y squared plus xy.
Looks good. Yeah, great. Okay, so you got that down. Excellent. Okay, so the next kind of strategy or thing that you might be asked to do is to solve something. And we talked last time about some options here. So I'm just going to snip in a question I found here that, again, according to this, it's a pre-test or placement test for the class you're trying to get into. Solve the quadratic equation. So the general rule here, generally, you want to get everything on one side of the equation.
Mm-hmm.
So you're going to do that by subtracting 6 from both sides. When it's in that form, you have options. And the first option, it's usually the best, is to factor. Quadratic formula is usually a good one because that generally works. You could be asked to complete the square, probably not. And then the last one is graphing your calculator, which you won't have one of those. So you got n squared plus 3n minus 18 equals 0. I'd like you to try to factor that on your own, please. Because you're trying to find two numbers that multiply to minus 18 but add up to positive 3. There's quite a few options. I'm going to write them all out here, and you'll notice that I go from negative to positive here because they both work. Negative 2 and 9, 2 and negative 9, negative 3 and 3. I'm sorry, that's really bad. 6 and 3 and negative 6. Okay, do any of those add up to 3? And hopefully you found this pair.
Yes.
So you get n minus 3, n plus 6 equals 0. This is where you got to pay attention to the instructions, because this time it didn't just say a factor, it said to solve. You're not done here. It might feel like you're done because we've done a lot of factoring. You have to set each of these equal to 0. And hopefully you got down to the final answer of n equals 3, n equals minus 6.
Yes.
Okay. So we're going to do this. We're going to do another problem here where it's just a slightly more difficult factoring. Solve the equation, quadratic equation. Just because it says quadratic equation does not mean you have to use quadratic formula. It just means that it's squared, power of 2. So much like the previous problem, you have to move this number to the other side of the equation because you want to get everything on one side of the equation.
Okay.
Okay. Now this one's different. There's not a 1 in front. Okay. And there's really two approaches here. Since I don't know what you're going to get, I guess I'm going to err on the side of the easier kind of way of explaining this. There's only one way to get 3r squared, 3r and r. Okay, but like let's just say it was 6r squared and then a bunch of other stuff. It's either 6r and r, or it's 3r and 2r. And there's another strategy to doing this, but that's a little bit more complicated. I'm going to just err on the side of hoping it's less sophisticated for you.
Mhm.
So so now it's a kind of a guess and check approach. What are the factors of minus 12? Minus 1 and 12, 1 and minus 12, minus 2 and 6, 2 and minus 6, and then lastly, minus 3 and 4, 3 and minus 4. So you check until you get what you think is right. So for example, let me put minus 1 and plus 12 in. If I multiply 3r and 12 and minus 1 and r, you get 36r minus 1r. And what are we trying to get? What would we like to get?
Negative 16.
Negative 16. So those weren't right. Those were not right. So I'm gonna delete those. And just as a reminder here, if you just flip the sign, you just get the negative of it. So like, I guess if I went plus 1 minus 12, you just end up getting minus 36r plus 1r minus 35r. I think you got positive 35r the previous time. So you actually literally want to try new numbers altogether. Okay, so let's try negative 2 and 6. 6 times 3r is 18r, minus 2 times r is minus 2r. That gives you 16r, but we want negative 16r. So what does that mean? What should I do for the signs here?
Flip them.
Flip them plus and then minus. So that gives you and that's kind of the guess and check approach. There is another way, but I'm shying away from it just in the principle of trying to give you the most information without overwhelming you. Set each of these equal to 0. And I want you to solve for each of these. The one on the right is 6, but give me the one on the left whenever you have it, please.
Negative 2/3.
Exactly. Very good. All right. So let's look at one more like this, because I think you'll have a good shot here. 5x squared minus 18x plus 9 equals 0. Because this only has one factor, okay, you can just say, oh, this has to be 5x or 1x here. You don't have to do this other thing that we did before that I'm going to avoid talking about unless we have more time. So you're using the factors of 9 now. 1 and 9, negative 1 and negative 9, 3 and negative 3 and negative 3, or 3 and 3. Okay, so it's kind of just guess and check. You're trying to get to minus 18. Which one kind of appeals to you to try first?
Negative 3 and 3.
Okay, so negative 3 and negative 3, they've got to be the same. And that is correct. You end up getting minus 15x minus 3x gives you minus 18x. Okay, but we're not done because it asks to solve. I didn't even write that. It says to solve, which means that you have to actually get a value for x. So you have to set each of these equal to 0. 5x minus 3 equal to 0, and x minus 3 equal to 0. So we know that x equals 3, and you'll tell me that x is 3/5 over here.
Okay.
All right, we should move to the more difficult type, unless there's another type of problem you want to solve. in preparation for this. Otherwise, I'm going to do the next type of factoring that you might see.
Okay.
All right, so let's just say it's solve by factoring. And it's 4x squared minus 15x minus 25 equals 0. The problem here is that it's not like problem here is that it could be 4x and 2x. So the strategy is actually to multiply 4 and minus 25 together. 4 times minus 25 is minus 100. And then now you have to find two numbers that multiply to minus 100, but add up to minus 15. Okay, and that's where this is a little bit, it's not necessarily the best because there's a lot of possibilities. So like it ends up being that -5 and 20 or 5 and -20 work for this. So what I mean by that is these numbers add up to minus 15x. They're not the things that factor. You end up writing 4x squared plus 5x minus 20x minus 25 equals 0. Do you remember this at all from last year?
Sort of.
Sort of. Okay. Well, and we're going to do more than one example, but now you look at the first two terms and you say, well, what's common between them? Well, there's an x in both of them. So this is 4x plus 5, because when you distribute that 4 in, you get, or that x, and you get 4x squared and 5x. And you end up writing this over here as well. It's factor by grouping. And you figure out, well, what goes here so that when you multiply in, you get minus 20x minus 25. So that's minus 5 there.
Mhm.
Okay, so notice that these are the same in both. So you end up factoring out of 4x plus 5, and then x minus 5 comes down from here equals 0.
Okay.
So once it's down to this form, you're like, okay, I got this. This is x equals 5, x equals minus 5 over 4.
Okay.
We're going to do another one. These are not my, I really don't like these because they're just challenging. So we're going to solve this. It's going to say 6x squared plus 5x minus 6 equals 0. So whenever this number is not a 1, and it's not something that just has one pair of factors, like, just to be clear again, like 5 only has one pair of factors and 3 only has one pair of factors. And that's why we could just use this kind of guess and check approach. But 4 has 2 factors and 6 has 2 factors. Okay, so here the strategy is you multiply 6 and minus 6. 6 times minus 6 is minus 36. You try to find two numbers that multiply to minus 36 but add up to positive 5. So minus 1 and 36, 1 and minus 36. This time I'm just going to write them all out. Minus 2 and 18, 2 and minus 18, minus 3 and 12, 3 and minus 12, minus 4 and 9, 4 and minus 9. Okay, I finally found them. It's all the way down here, right? But we're not done factoring yet. Like, that's just breaking this apart. It's literally breaking 5x into minus 4x plus 9x because of those numbers there.
Mhm.
And in the previous problem, that's what we were doing. We're like, oh, minus 15x is really 5x minus 20x, 5x minus 20x here. So we're just breaking it apart. 6x squared minus 6 equals 0. And then you do factor by grouping. You say, okay, what goes into both? What's the greatest common factor in both? That's why we did that practice first. So you're looking at the numbers 6 and 4. 2 goes into both, and it's the smaller exponent for the x. So 2x, 3x minus 2. You multiply that in, you get back to this previous line. So then you immediately write 3x minus 2 here equals 0.
Mhm.
And then you figure out, well, what goes here? What goes here so that when you multiply and you get back to 9x minus 6, well, you can say, oh, it's plus 3. And then 3x minus 2, 2x plus 3 equals 0.
Okay.
So you set each of those equal to 0. Oh, I can't find my cursor. There it is. I need to move down. So you set 3x minus 2 equal to 0, 2x plus 3 equal to 0, x equals 2/3, x equals minus 3/2.
Okay.
I would definitely review these two examples again, and or if you've been copying your notes, try to work through them at least one more time to make sure you've got it. Okay, so let's look at another type of solve factoring or solve a quadratic question that you might see. You might see something like 9x squared minus 16 equals 0.
Okay.
Now, this one only has an x squared in it. Okay, it doesn't have like 5x or 4x or whatever. You can, I call it direct solve here. You're literally just going to get this x squared by itself. You want x squared equal to something. So you're going to add 16 and divide by 9.
Okay.
Now, this is very important to remember. When you take the square root, it's two solutions, plus or minus the square root of 16 over 9.
You have a neutral face, but sometimes like your eyes are like wide.
So here you've got two possibilities, plus or minus
A resting, terrified
the square root of I'm sorry, you're going to do the positive one.
There's no chocolate.
Okay.
So it's like positive square root 16 over 9 and negative square root 16 over 9, but you can reduce those. The square root of 16 is 4, square root of 9 is 3, negative 4 over 3.
Okay.
Like somebody breaking.
So let me have you try one more of those. Let's see here, 25x squared minus 100 equals 0. Go ahead and solve that for me, please. So here, when you direct solve for x squared, you should get x squared equals 100 over 25. And
Yeah.
when you take the square root of that, it's plus or minus the square root of 100 over 25, but you actually know both of those values, or you could have even reduced here, but if you didn't, that's okay. What is the square root of 100?
10.
10, and the square root of 25 is?
5.
So it's really just plus or minus 2 as your final answer.
Okay.
All right, well, that takes us to the end of our lesson here. Thanks for scheduling, and really thank you for being so kind to me for my technical difficulties. They were resolved by reinstalling Zoom. So if you ever have your Zoom's not working, maybe reinstall it. That's what I figured out.
Okay, that's good to hear.
Hope you do well on your placement test tomorrow, and I'll be available to help as needed.
Okay, thank you.
Thank you. Bye now.